Our first talk, Ahsan is going to present customer churn predictions, segmentation and fraud detection in the telecommunications industry.
All right, thank you so much. Yeah. Good morning, everyone. So I'm Ahsan Rehman, currently a graduate student at Northwestern. This talk is more related to telecom industry. This is the outline. So we have introduction. I'll be explaining what we did, what's really the key objectives, the business challenges which needed to be met for this project, for this research paper, what was the system overview, what was the methodology, especially with data, with big data or any analytics project, you need to understand the data, need to prepare it before you start that modeling and all that system thing. We'll be discussing that, and I'll have my results and then the conclusion. So starting it off, I'll just give you a very brief and simple introduction. So these days we understand that everyone has a cell phone, which means mobile carriers have already split the whole market. Everyone is having a communication medium through mobile phones. What does this mean is we don't have new customers coming in. We have to retain our old customers because according to research, acquiring a new customer is really expensive these days. You need to give them new promotions, and it's better that whatever customers you have at the moment, you start retaining them. You make sure they don't go out of your network. And if someone leaves your services and goes to another network, which we hear and say port in facilities, that's called a churn. So a churn is any subscriber who's leaving your service and going out. So what we are going to target really is predict people who are going to leave your network in future and then try to prevent them from going out. So we'll be studying different techniques. How could that be done? So we'll be discussing churn prediction, churn prevention, how you must have seen some good offers coming from your mobile carrier which says how many free minutes or some internet packages. How do they get to know all this while you're really frustrated from your network? We'll be discussing that. And then, for example, a subscriber with a 300 million base, how could he make sure you are a specific customer with a specific requirement, you are doing a lot of calls, you don't do much text or internet? How does he know that specialized offer for you could be managed? We'll be discussing that. And then the last very important key thing these days is like, for the traditional algorithms, we always understood that a person is responsible for what he does. But in social networks, we realize that you are being affected by your peers. For example, we see these family packages coming up. What does that mean? Why are they being built? So it's actually that one person is influencing a lot of other peers. That social network analysis will be discussing how we utilize this for understanding when a customer could leave your network and how could he be better managed. So taking up next, these were the business challenges which we had. Number one, the data set we had was primarily for prepaid customers. So with prepaid, we mean people who put the credit first and then they start utilizing your services. So the major base was prepaid. But the problem here was that this base was had a really big spread outline, was from $1, average base coming for a month from $12. So you have a really big split base, which is not just uniform, it's really split according to different revenue criteria. Then another phenomena for this data set was early churn. So what is early churn was, you get a new number for this company, it was like giving you a new activation and they give you some free credit to enjoy. So you initially get the new number, you start using the credit until first 7 days you can use this $10, and after that you need to recharge. So we saw customers they used to get a new number, they used to get new activations, they used to use the $10 recharge for first 7 days and then they are gone. So that didn't make any sense. Company wants them to put some balance, give them credit so they can earn revenue, but this was not happening here. So this was early churn phenomena which we had to really build a model to understand and to try to predict those customers who are going to not recharge, so the company could pitch some offers to them so they could start recharging back. Then we had fraudulent activations where we see new activation in the system, but we don't get revenue from those activations. That was another key challenge for us. Then the subscriber churn was largely affected by the influential peers, which means you are doing good, you're giving us good revenue, but then you are gone. Why were you gone? Because this was not your decision as a peer, as a group, everyone is going from the network. That was something which we had to track. Coming up next was that data set. So the characteristics I'll explain, we had 3 basic models: prepaid, which was around 20 million of the subscriber base. We had postpaid, which was around 0.1 million. So postpaid is typically you use the services and the end of the month you pay the company. With prepaid, you put some credit before and then you start using it. So the major base here, which we had to focus, was prepaid. And then the early churn model, which I discussed. So for different models, we tried to get maximum data which we could get. For early churn, we had 7 months and was 3.7 million new subscribers. For prepaid was a major base, 20 million, 6 months, that was already enough for postpaid, it was a 0.1 million. And we really wanted more data. So we tried to get maximum 12 months data. So coming up with the basic outline, what are the features or what you call as variables which we could get from, which we could use to understand this pattern of churn. So we had CDRs, which we usually say customer call detail records, which says which calls you made, what was the how much was the duration of that call, what was the revenue earned, how many SMS short message services did you use in a day or maybe in a month, how much revenue did the company, and then all the value added services, especially internet. We have this MMS, interactive voice response, all that stuff coming up. So we got this information, the recharges, did you pay through a credit card or cash? For prepaid, how much did you recharge? How many times did you recharge a month? All that stuff coming up. Another major aspect we tried to cater was how many calls you make to the customer call center. If you have any problem, you'll be sending out a call, you'll be talking to any representative. So how many times did you call and what was the duration? Was it like a 30-second call or sometimes it extends to 5 or 10 minutes, which means there's a serious issue. Then we tried to get some personal information, which was not really was successful, only was activation date. We got the gender of the person and the location from where he was making most of his calls. For example, which city was he primarily consisting of? So we could understand like if there's a network issue coming from which city, and that's where people are going out from that location. So these were the input data sources which we got. After that, we started thinking of more variables which could actually help us in understanding the behavior of the customer. So we had active days. For example, in a prepaid data set, you are 6 months data we have. How many days were you actually making call from your cell phone? Did you give any revenue every day? And if not, what was the average distance between your calls? For example, you called once a week, which means only after 7 days we get a revenue from that. So that's average call distance. Then how many days for consecutive you were simply blank? You didn't do anything. For example, for 1 month, there was no revenue being earned from your number. That's one more thing we tried to capture. Network age, how old is the customer? That's important. For example, a 10-year-old customer, a 5-year-old customer, you don't expect him to just leave the network in one day. He'll do something, he'll call you, he'll try to engage with you. But for a new customer who just started 1 month ago, you can expect he can just go out any day. So then we took the averages of the data, we tried to find out the trends, like is the revenue increasing, decreasing, which we call as deltas. So month to month change, is it going good, is it going bad? So if we can track that, we can understand, for example, 50% utilization has dropped, which means he's not satisfied with the network or what else. So that's what we built in our data set. The first step was to get the data, put more things into this. Coming up next is the most painful thing is the pre-processing. This really takes like 70% of the time of your project, is that cleaning the data, preparing it before you take it for the algorithm thing. So first we did was data audit. We tried to understand what's the mean, standard deviations, maximum, minimum values. For example, in revenue, you don't expect a negative value coming up. You try to understand if there are any outliers, extreme values in your data. That's what data audit just gives you a complete picture, which is called this descriptive analytics. You use statistic techniques to understand the data to summarize it. The next step was missing values. We had some missing values in the data. So accordingly we discussed it. They had nulls, and nulls could be replaced with zeros. So we tried to capture those missing values. We had outliers, extreme values. We tried to find out the mean and the standard deviation greater than 5 or 3. And then we tried to just put the most dirtiest data, like only 1%. Why was it 1% of the data we discarded? Because we really didn't want to just leave everything out. We really wanted to capture most of the information. So we just tried to make sure only 1% of the really outliers were just put aside. We did some correlation analysis to find out what are the actual key variables which are affecting the churn. Is it the calls? Is it the maximum and active days? What is the key things which we can find out and really help us build the model? Then one more aspect which was really important for us was data balancing. For 100% customers, 8% of the people, for example, go out of your network. 94% are still there. So when you run a model, you automatically create a lot of biasness in the model. Model will always favor the 94%, which you really don't want. You want to figure out what are those 8% or 6% of the people. So what we try to do is we studied some of the techniques like undersampling, oversampling, and really tried to use this technique where we removed a small percentage of the active customers, like 8%. So we had a ratio of 16 to 94%, 16 to 84% of the ratio for the data balanced for churn versus non-churn. So coming up next, this was the data quality analysis. So I'll just discuss some of the major things we found out in the data, which I would like to mention. So you see, this is 0 active days. So we had a data of 3.7 million. And out of these, around 18% of the people didn't do any activity. For example, you get a new activation, you get a new number, and you just put the number aside, and you don't do anything. Does it make sense? No. You get a new number, you should be using, specifically if you're getting free credit in it, like $10, you'd always like to utilize those $10, no matter what happens. But here, 18% of the people we saw were doing nothing out of it. So that was actually what we discovered was the fraudulent activity. So you have set some aggressive sales target to your franchises and say, just sell these numbers. So they were doing activations to earn the commission and showing we got so much targets achieved. But there was nothing being done on the back end, which was really a stress call for the company that, look, what is this happening? Then we tried to understand the 7 days, actually the criteria, like after on the 8th day, the company said, okay, now you need to recharge, otherwise I'll confiscate your balance. So the company was thinking like people use the number till the 7th, they try to utilize maximum balance and then they stopped using it. So what we really wanted in this model was, early churn was, try to predict whether the customer will recharge again or not. And if he won't, we will try to pitch him some good offers so he can start recharging our network and it gives us more revenue. This is one of the key models. Then we had the postpaid model. Can you see the spikes in this data? This was really disturbing for us. A customer is just so new with less network age, like he has come for 1 month and he's giving you so much revenue. That's something which we normally don't see. Normal customers are giving you this much revenue, but few of these are so big. So we really tried to understand what's happening in this postpaid data, which was only 0.1 million, but you're getting so many spikes. So the idea was to remove these spike numbers because actually when we discovered they were not part of the general base. So there were around 40 numbers which we discarded and we tried to keep them uniform. That's the postpaid. The third one was this prepaid, which was the 20 million main chunk earning customer for this company. So we had high diversification segments. We had people from $1 to $12. We see people with older, they have been with the network for more than 3 years. Some of them are very new. Some of them are tech savvy. Some of them use a lot of internet. Some of them are more prone to bundles. Some like to make payments through cash. So all this stuff really showed us there's a lot of diversification. And the customer generating the revenue, there's another problem. So for the 6 months data we are getting, we ideally want people to be using the network for 6 months. But we found out through active days, through maximum active days, that people would just used to come for a few days, use the services and then go out. What was happening in this case? We really tried to figure it out. And we tried to understand if we can divide the whole base into some generic clusters. Like, look, these are the people who are really always giving you good revenue. They're sticking with you. They're making calls on daily basis. These are the people who just come on the weekends or the start of the month. What is happening? So this was explained in this prediction model, which I'll discuss. The interesting thing which I would like to highlight is you see these green lines. These are the people who leave the network. That's churn. So the interesting thing here is at the start, at the end, you see even with the older network age, people are still going out. So which should not be happening. A person who is sticking with you like 5 years and still he plans to go outside your network and go to some other network, which is not the good thing, which the company is really distressed about. So we tried to figure out what was happening, and there were some challenges in the traditional algorithms because of which we moved towards social networks and tried to figure out and how we could solve them. So then another model was the customer segmentation, which I talked about, was dividing the bigger base of the prepaid customers into segments, which had the similar characteristics, and we could target them in a good manner because everyone wants a suit which fits him. He doesn't want a big, large or extra large suit. So what we would do is group them into some characteristics and take them into some groups and then give them good offers. So that's customer segmentation. The variables we used was average revenue. How much are you giving me? Are you really active or inactive? What of the packages are you using? Are you most of tech savvy? Are you most of the SMS thing? You're using $100 package or $50? In that case, it was not like it was $10, $5 packages. So we try to understand all this through customer segmentation. Moving up next, this is the key thing, the system architecture, how it all works. So you have the data in the data warehouse. You use SQLs and procedures to bring the data inside, the training data. What's the training data? It's the historic data, where you have the data and the results as well. Now you're going to train your model. We did the pre-processing, which I discussed, data audit, handling missing values, outlier detection. After this comes the key modeling part. Here we try to use some of the decision trees. I'll explain why we tried to focus on just decision trees, although there are a lot of techniques for this supervised learning which you can use. So we really use data modeling. We try to get a good, accurate model. We try to get the rule sets out. Why is a person being declared as a churn or as a non-churn? Can we get the reasons? Because for telecom, telling him that he's going to go out is not enough. They want to know the reasons. Why is he going out? What is going drop? So they can pitch in similar offers. For example, a person is making a lot of calls and you say, I'll give you 100 SMS. He won't stop. He'll say, I need calls. Why are you giving me SMS? I need a similar offer which matches my trends only. Then I'll stop. So that's what we got the rule sets out. Then we created the model, and this model was then used for scoring. So now you give me a fresh data, which you just like the data from today, and you say, tell me in next 15 days, how many customers are going to leave the network? Can you just tell this to me? And here it is. We give you the scores, like these are the people who are going to churn, and I rate them according to this churn probability score, and you're going to pitch them some good offers. Here comes the churn prediction. And the other thing is the customer segmentation, where you used k-means and two-step clustering to get those segments. And then these segments were actually used to track for the next month. For example, I put the data inside those segments and see which customer fits in which segment. So if you're moving from a $5 segment to a $3 segment, that's a problem which we need to really figure out. We need to give you good offers. We actually want people to moving towards more revenue generation. So this was the customer segmentation part, which we did. Okay. The problem doesn't end here. When we did this first churn prediction using decision trees, what we found out was that everyone is not just doing because he is like people are already giving us good revenue, but still they are churning out. And sometimes people just come again and don't actually churn out, but the revenue is so low that our model is saying that it's going to churn out because they just come back after every 30 days or 45 days and they just come back, use some services and go out. So how we can figure out what is happening? So we started using this social network analysis, where we try to get the number of people who are calling, who are receiving. I'll just end it up. Calling and receiving. And then we try to find out the durations of the calls. How many minutes did they call? And we tried to use the previous algorithm which was coming up, which was giving us the results, this churn modeling. And we actually tried to understand if we could figure out if a person churns, does he affect other people, the diffusion energy? Does he, like, if you're calling someone and he plans to leave the network, there are chances you'll also need the network. I just have less time. I'll have to finish up with the results. So actually what I'll just try to focus here it is that we got a good prediction around 70% from the postpaid and prepaid model. But when we used social network analysis and we tried to figure out what's happening for other customers, if you're going to change, are you going to affect other people? So it actually boosted our results, and we really got some good accuracies coming up, 9% in prepaid and 7% in postpaid. We really boosted up this whole idea by using social network analysis, and this was the result. And in the group analysis, the customer segmentation, what we did was, we already have 10 clusters coming up from k-means, but that's not enough. For a 20 million base, where you have 18% of the people from in one cluster, you can't pitch everyone. So what we did, we used group analysis through social networks, and we really tried to find out the social leaders, the influential people in the group. If you send them the offer, they'll automatically spread it the whole group. That's the idea of group analysis. We have two results, just I'll brief it up. So what we did in the conclusion was, we split the 20 million base into 10 clusters. We tried to predict people for the next 15 days. You can say they are still in the network. You need to send them some good offers. We try to track the migration from cluster to cluster and all that stuff. And the future work which we did was, like, if you get more features related to call quality, what was the number of call drops? If you use text analytics to see what is the sentiment of the person, is he happy when he calls the call center? Is he angry? All these things can really build up a good model for you. That's it. I actually have to finish up because of the 20 minutes constraint.